Hi there, intermediate algebra students, and you're stuck with me, Mr. Plocker, for this chapter of videos. This is a fairly short chapter, but very important in the big scheme of things as far as algebra goes. This may have been something you've done last year, so hopefully you'll be able to catch on fairly quickly to it. This whole chapter is on something called systems of equations. And here's what we mean by a system of equations. There has to be more than one. Typically in this chapter we'll look at two equations at a time, although we could have a lot more than that. We're always looking for a common solution. And typically then it'll be, as you can see on this graph, where do these graphs intersect? And the solution then is actually an ordered pair. So rather than our solution just being one number, it is almost always an ordered pair, an x and a y. Now, this first lesson we're going to look at solving systems by graphing. And we have a few other algebraic methods we'll use later on in this unit, but first today is we're looking at solving them by graphing. Alright, so we're going to look at our very first example here, and we're going to graph this to find the solution. Notice we have our yellow equation here and our red one. I'll try to graph them in the same colors so you can distinguish them pretty nicely. First of all, our yellow one, you can see that's in slope-intercept form. So we first of all want to graph that y-intercept of 4. So I'll put my dot right there. And when you don't see any number in front of that x, you know that it's the number 1. So basically I go up 1 and over 1 and up 1 and over 1. It's a positive slope. So it looks something like this. I can also go down 1 and back 1 like that and so forth. So my graph will look something like that. Okay, so far so good. Now we're going to try the red one. Now notice this is in standard form, and we can get it in the y equals form easily enough. I'll try to do that in this case. So I'm going to subtract 3x from each side. And after I do that, I end up with 2y equals negative 3x plus 18. Remember, I can't put those two together because one is an x and one isn't. Then I'm going to divide by 2. And so I get y equals negative 3 halves x plus 9. So my y-intercept then is 9. My slope is a little strange, negative 3 halves. That means I go down 3 and over 2 like that, and down 3 and over 2 such as that. And I could do that one more time. So I just get a good looking graph like this. And sure enough, there's my graph of my second one. Now what do I say for my solution? I'll change colors here. My solution is where these cross, and sure enough it looks like it's going to be this ordered pair right in here. So my solution looks to be the ordered pair 2 and 6, I think, right? And I can double check to make sure that that works. Notice if I put 2 in place of my first equation, that seems to work. And also 2 and 6 does seem to work in the second one as well. So just as we did when we solved regular equations, when we get a solution here, it's fairly easy to check to see if we have done it correctly. The slide, you probably want to pause and copy down a little bit. This has some terminology here that's kind of good to know. It's not the most important thing in the world, but it does give you some ideas when you hear these terms thrown around here a bit. So we have really three things that could happen when we graph two lines at once. We might have two intersecting lines, and of course that would look like this. And if that happens, then there is just one solution, of course, exactly one. The terminology we use there is consistent and independent. Consistent meaning at least one solution, and independent meaning only one. So those are the two words we use there. Now it's possible that when we graph a system of equations, maybe the two equations look different, but maybe they're actually the same line. That can happen sometimes. So then the solutions are infinitely many, not just one ordered pair like there is here, but infinitely many. The terminology we use is consistent, consistent meaning at least one solution, but dependent meaning there is more than one solution. And lastly, we have parallel lines, and of course if we sketch those out a little bit, we know what those look like. And of course then we realize, why is there no solution? Because they never cross. In order to have a solution on these systems of equations, these lines have to cross. So because they don't, there's no solution. The terminology we use there is inconsistent. So anyway, good to know what those words mean, but not the end of the world. If you don't, all right, one last one we want to take a look at here. Graph this system of equations. And so I'm going to have the green graph here. Again, this is in our slope-intercept form. Pretty nice. So my y-intercept is at 7. I go up 1 and over 3, like that. Up 1 and over 3. And I can go down 1 and back 3, like that as well. So sure enough, there's my first line, like that. Easy enough when they're in slope-intercept form. Now my second one, this time I notice that this is in that standard form again. I'm going to try solving this with this intercept method. So that's when I put a 0 in for x and see what y is, and a 0 in for y to see what x is. So notice if I put a 0 in for x, again, then the x kind of cancels out a bit. So negative 3 times y is negative 6. That's got to be a 2. And if I put 0 in for y, that whole term is gone. And then, of course, x has to be negative 6. So I have 0, 2, and negative 6, 0. And notice when you graph this, what's going to be true? Well, these are parallel lines, aren't they? And so parallel lines, like we saw on that other slide, there is no solution there. No solution. The graphs never cross. There's never an ordered pair that's in common, so we say that there is no solution. Remember, the other thing that could happen is maybe the two lines here happen to be the exact same line, just written differently, and then there'd be an infinite number of solutions. So again, this just builds on our skills of being able to graph linear equations, but now we're looking at more than one of them, a system of equations. So hopefully all systems go and are ready to work hard and keep tackling these systems of equations when we get to class tomorrow. All right, thanks for listening, everybody, and we'll see you guys in class.